In this section, we're going to start learning about long-term memory. Long-term memory. Now, in a previous section, we learned about short-term memory. And to better understand what long-term memory does for us, we still have to go back to short-term memory to see some of its limitations. So, I mentioned when we were discussing short-term memory that you have your graph in a session. So let's say you have a graph with these nodes, any type of graph, and connected with your edges in some way. You can contain it in a single thread. You can contain that graph in a single thread. And that thread is going to represent a session of the graph. So this is a thread. Let's call it thread 1. So this is a session. And a very easy way to understand it is when you think about it in terms of going into ChatGPT and starting a new chart. So that is a new thread. When you open a new chart in ChatGPT, Gemini, or Claude, that is a new thread. And every single time, requests are sent through this thread and responses are sent back, the checkpointer, which is responsible for short-term memory, is going to save the state at each node. It's going to save the state at each node. Each node that the graph passes through is considered as a super step and a checkpoint for the checkpointer. So the checkpointer is going to save snapshot of the graph state at each checkpoint. So we know that. You know that from short-term memory. Now, let's assume the user then comes and starts a new chart. Let's say this chart was started on Monday, and the user comes on Wednesday and starts this new chart. Here, the user has already mentioned their name, they've talked about their profession. Let's say they were just having probably they want to ask questions about how to create a CV, a curriculum vitae. They want to ask questions about how to create a CV. So they already dropped their name here, they already dropped their work experience and other information like that. They've dropped all those things. And this thread is aware. This thread knows the user's name. Oh, you're Sarah. You've worked at Microsoft. You worked at IBM. You've worked at Salesforce and all that. You graduated 2015 or 2007 or whatever. So this thread is aware of all that through the power of checkpointers. But then the same user, Sarah, comes on Wednesday. This is Monday. Comes on Wednesday and opens a new chart. The chart is running the same graph. Opens a new chart and asks about the types of companies she can apply to based on her work history. This thread is not going to be aware of that. Yeah, this thread is going to tell her that it's not aware of her work history. Oh, this thread will most likely say something like, yeah, please supply me your job history so that I can make the proper recommendations. And the user will be like, but I opened a chart on Monday and I already told you all that. We already discussed all that. How come that information cannot be recognized by this new thread? And that's because checkpointers only save information within a particular thread. They only save information within a particular thread. Their information does not transfer from thread to thread. It doesn't cross threads. So all that discussion you had on Monday, yeah, on Wednesday, it's not aware. The chatbot is not aware. So sometimes this can be required. Sometimes you want to keep each thread separated, walled from each other. But in a chatbot scenario, like we've seen with Gemini, we've seen with ChatGPT, and for a lot of production applications, there are some core things you would like to remember. Of course, you don't want to remember every single thing they talked about. They probably passed 70 messages in this thread. You don't want to remember everything, but you want to remember important facts like the user's name, the user's email, the user's job history, the user's preferences, some of their likes and dislikes, and stuff like that. You want to remember those type of important information. And that is where long-term memory comes in. Long-term memory allows you to share information between threads. It helps you to share information between threads. So you have a user that is opening up these threads, Sarah in this case, and what long-term memory does is that it maintains a store. A store is maintained. It maintains a persistent store. A store that when you close the application and come back is still going to retain information. It maintains a persistent store. So if the user comes here and starts interacting with this thread and says that their name is Sarah, this store will automatically store that information. Say name Sarah. Let's make this store a little bigger so we can put more things inside. And let's just make this medium. Okay, so this is going to save that. That's quite important. Our name is Sarah, so let me save that. Then they continue to have their interactions back and forth, talking about the weather, talking about Los Angeles, or talking about Lagos in Nigeria, or anything like that. And the user mentions that they schooled in Berlin. They schooled in Berlin. Oh, that sounds important. Let us put that here. So schooled in Berlin. So school, Berlin. Let's say that's where they add their higher education. So school Berlin. Then they continue to chat on, and the user says that, yeah, I'm a software developer. And oh yeah, cool. Occupation, software engineer. So this store continues to track the conversations that is going on in this thread and saves important facts into memory. So that when this user, Sarah, comes back on Wednesday and she opens up this thread, she just needs to say hello, and this thread will be able to access information from this store and reply her by saying, hi Sarah. She just said hello in this new thread, and the thread will say, hi Sarah, what can I do for you today? You can even go further and say, oh, would you like to learn more about your school in Berlin or projects you can take on as a software engineer? Because there is a store that is persistent and is able to share information across threads. So that's basically how long-term memory works. That's how long-term memory works. And if here Sarah says, oh, I don't want to talk about my job today, I'm trying to go on a date and pick a very good restaurant for myself, but I have a nut allergy, so I want to make sure that the restaurant doesn't serve anything that would trigger my allergies. Then the long-term memory will quickly say, oh yeah, that's a fact. Allergies, nuts. Yeah, it saves that, it picks that, and it saves that. So it is gathering information about this user and is using those information to inform its responses, to provide better context for its responses. And that's where all these chatbots or AI systems starts feeling like they know you. It's because they are storing more context about you the more they discover facts about you. So that's basically how long-term memory works. We have a store that can feed information into multiple threads. That's how long-term memory works. That's how it bridges the information gap or breaks the information wall between threads. Fantastic. The checkpointer information still stays within here, and the checkpointer basically saves everything. So unlike the store, the checkpointer is saving everything in state. It's saving everything in state. It's even saving it per super step. It's saving it per super step. Every single thing, so that anything you're talking about within the thread, it is feeding everything back to the LLM as context, because the LLM remains stateless, feeding everything back to the LLM as context, and is returning appropriate responses. But what the store is basically doing is storing important facts, important information about your preferences, about your location, about different key things that don't really change that much, and it can be tagged as an attribute of the user. That's how long-term memory works. To wrap up, let us look at some of the things that long-term memory aims to achieve. We've already discussed a bunch of them, but let's just put them on the board here. So first is cross-thread persistence. We already discussed that extensively. Cross-thread persistence. Like I said, let's make that large. They enable you to share information between threads. So you can share data across multiple threads, across multiple conversation threads, just as we have mentioned. Also, you can get user-specific context. User-specific context. So you can be able to reply based on the user's preferences, users' likes, their dislikes, their history, and stuff like that. Another one is the ability to store application-level data. So sometimes you're not storing facts about the user, you're actually holding information about the application itself. Not everything is going to be a chatbot, but you can store some configurations, some settings, and some metadata, some global metadata inside your long-term memory for your application. So that's one one other thing you can do. Another powerful feature of the stores used for long-term memory is semantic retrieval. Semantic retrieval. So you don't just find memories based on exact matches. You can actually query memory based on meaning. You can query memories based on meaning. And we're going to be looking at an example where we use semantic retrieval. Also, it provides a structured memory management. Later on, we're going to see how memory locations can be constructed using namespaces for long-term memory. So structured memory management, you can perfectly organize your memory based on hierarchy and type. So structured memory management, and we can also scale our memory because these long-term memory systems are backed up by tried and trusted databases. So you can always scale up to provide more memory that can be accessed by your LLM application. So that's how long-term memory works. We're going to be going into more details about how we can implement long-term memory in the coming videos.